Okay, guys, so let's get started. Just one thing before, you might see over here that on the modules, I'm posting the lecture of the links. Okay, I'm going to do that until we run into technical issues. It happens, I'll tell you right now. So take notes. But basically, here you see that I'm trying to add some stuff about this is like a FEMAP, like I did the other day in class. This is not that much. I'm not expecting that you need to know it, but if you watch this video, this should help you to validate or verify the problems on the assignment. Okay, or some of the examples that we do in class. Okay, and here I will be putting the assignments answers. There's a difference between answers and solutions, no? So do not expect to have the solutions. I'm just going to provide the answers, meaning that if you don't find the right answer, you might have to go back once you have your assignment to see if you can find, you might have to go through your solution to see if you find the right answer. If not, you can come to my office and I can check what you're doing wrong. Okay? But basically, over here, the other thing that will be posted will be the answer. So basically, the final answer that is expected from the assignments, no detailed solutions. Okay? The reason is because I want you to make you work out the solution, not that you just wait to have the solution in order to start. Okay. So, all right, so let's do some more examples. Obviously, we're going to add something. I think you have your first assignment due. Is it this Thursday or the following Thursday?
The next Thursday.
Next Thursday? Okay. So one thing is that about the assignment, if you do the final element, which is very quick, you're going to get the solutions. You get the answers very quick, so you can check your answers. Okay, so we're going to do another example. This one is really very simple, but it's not that much about the difficulty. It's about more about the two different ways we can actually solve this problem. So let's say you have a frame like this. Here is going to be simply supported, and at the other edge, we're going to put a roller. Okay, we can call each one of these 1, 2, 3, 4, 5, and 6. So remember, this is stiffness over here. Okay, and here you're gonna have panels or frames. Okay, so over here, let's say will be our panel Q1. So we can do our shear flows this way. Okay, let's say that this stiffened panel is going to have a force over here of 2,000 pounds. And here, 1,600 pounds. And basically, let's say they ask you here, determine the reactions at points 1 and 3, and shear loads Q1 and Q2. Okay, so this is a very simple problem. The reason I'm doing it is because I'm going to do it using two different approaches. Okay, so let's say method 1, which would be the traditional one. So it's like we have been doing so far. First, solve for the reactions And then for the shear force. Okay, so basically this is like if you want a bit more advanced problem of statics. So it would be step one, you always need to do some free body diagram. Okay, so over here, it's 1, 2, 3, 5, 6. So let's keep the forces over here of 1000 LB. 1600 LB. Now, in order to find the reactions, what do we need? We need to remove the reactions, and then what's going to happen? Then here at 0.3, since the row, that means we're only going to have a reaction on the vertical direction, no? Okay, here is a pin, so what does that mean? We're going to have one on the vertical direction, R1, but we're also going to have another reaction on the horizontal direction, so let's say H1. Okay, if you want, we can still leave over here. All right, let's leave it this way for the, let's not confuse anything. So this is statics. Step 2, apply equilibrium equation. So what are the two equilibrium equations? Summation of forces equal to 0, summation of force equal to 0, and summation of moments equal to 0. So if we do the summation of forces, let's say on the x direction, what are we going to get? H1 plus 2000 equal to 0. So in here we can solve right away. We will get 1. H1 should be equal to what? Negative 2000 pounds. Okay, next, what can we do? We can do summation of forces on the y. So what will we get? We'll get R1 minus 1600 plus R3 equal to 0, or this will give us the equation R1 plus R3 equal to 1600. Let's say that would be our equation 1. Okay, so here we have one equation, one unknown, we went and solve. Here we have one equation, two unknowns. So what do we need to find? We need to find an additional equation. So what will be the additional equation? Will be summation of moments. When you apply the summation of moments, what do you need to define? Does this equation make sense as it is over here? Yes, no?
About the point.
About a point. You don't say about which point, this equation is useless, no? So let's say about point 1. Then this is not that important, but I like to put it. You also need to define a direction for which will be positive. If you don't put this, I will always assume that counterclockwise is positive because that's the normal sign convention. Okay? So basically, all the equations, you see over here, all these equations come from a figure, no? If there is no figure, there is no equations. If I don't see an R1 and H1, and then I see equation with H1, R1, where is that coming from, no? Okay? Okay, so let's take notes about point 1. So this will give us what? Let's first look, maybe I need to put some distances. So let's add over here, this will be 10 inches, 20 inches, and 10 inches. So let's put over here 10 inches, 20 inches, 10 inches. Okay, so what will be the equation? What will be the moment created by, let's say, R3? Will that be clockwise? Will that moment be positive or negative? Positive, so R3 will be the force. The arm is 30. Then what will be the moment created by the 1600? Will that one be positive or negative? Yeah. Negative, so minus 1600. What will be the arm? 10. And now what will be the moment created by the 2000? Positive or negative? Positive. We will go clockwise, so it's negative. So 2000, and what will be the arm? 10 again. Equal to 0. So from this equation, you can trust me, if you solve for this, this gives you 36. You add these 2 divided by 3. So 36 divided by 3 will be basically 120. Plus if you put the 0, this gives you R3 should be equal to 1200 pounds. Okay, 36 divided by 3, 12. No? Yep. Okay. So now, what can I do? From equation 1, so using equation 1, and from equation 1, what can you say? You can say that R1 will be equal to 1600 minus R3, which will mean that R1 will be equal to 400 pounds. Okay, next, let's say, so we found the reactions. To determine the shear flows Q1 and Q2, let's apply the equilibrium equation, summation of forces equal to 0 to, let's say, each stiffener. Really, we don't need to do all of them. So basically, I want to redo a figure, even though we reuse this figure here. So we are over here. Q1. And this is Q2. So let's see, which stiffeners or which flanges can we consider in order to find Q1 and Q2? Okay, so what about we look at the stiffener? One six. So what do we know about 1/6? Remember, we know we make the assumption that each stiffener is what? Is what we call to be a one force member, no? Can only carry load on the x direction. So I'm not going to put the H1 because the H1 should be carried by which one? By the lower one, no? So after I1, then what are we going to have? This should be over here, Q1. We know this is 10 inches. So if I look at the stiffener, now I apply the equilibrium equation. Summation of forces equal to 0 is going to give us what? I1 minus 10 Q1 equal to 0. And we know from above that I1 is equal to what? 400. So basically we can rewrite over here that then Q1 is going to be equal to what? I1 over 10, which is 400 over 10, which is going to give you that Q1 is 40 pounds per inch. Well, before I forget, because one of you asked me at the end of last class, I had no idea. I was under the impression that everybody, because they are trying to do that at the college level, that everybody had to use the same syllabus. Okay? But they're not doing it over here. But I think you will find out over here that basically, I think that's what you were interested on about the grade distribution. Okay? How it's going to be calculated. So basically, maybe you have seen this stuff 20% on the assignments, 20% exam one, 20% exam two, 30% the final exam, and 10% the final project. I think that's what you're interested, no? What the college is trying to do is to tell the truth is that independently of the different sections for the same course, that everybody should have the same grade distribution, but they are not doing it on this course, okay? I'm not in favor of it, to tell the truth, but it is not up to me. So anyway, just wanted to point out that. So we have this. Okay, so now, in order to find Q2, I mean, you can use different ones, but what should be probably the easiest one? What number can we consider next? So let's say next I'm going to look at the number here 3, 4. And knowing that this is only on the vertical direction, I'm going to put here R3. And then what are we going to have? We're going to have over here Q2. And this would be also 10 inches. So what did we find before R3 to be? We found R3 to be 1200. Okay, so we do summation of forces again. What are we going to get? Then Q2 plus R3 equal to 0, which will give you Q2 is equal to negative R3 over 10, which will be negative 1200 over 10, or this will give you that Q2 is equal to negative 120 pound per inch. Okay, so this is statics, okay? Basically, we didn't do it. All right, so because of the space, I'm gonna put it here, continuous. Next page. So method two, so for method two is let's write the equilibrium equation summation of forces equal to 0 for all members. So what should be the members? Should be member 165234, no, for the vertical members, and for the horizontal 654 123, no? Okay, so if you want, let's do first vertical members. So what should be our vertical members? We have over here. So basically we have the two that we had before, plus the one in the middle. Okay, so let's see, this should be 1 6 2 5 3 4. If I look at them, this should be over here Q1. This should be over here R1. Then the second member, we have over here the force of 1600. Here you will have Q2. Here you will have Q1. 3 4, you will have here R3. And you will have Q2. Okay. So let's say this is 1, 2, 3. And now let's look at the horizontal members. Okay, so what would be the two horizontal members? Should be 654 and 1 2 3. So maybe let's do first 1 2 3. So let's see. Let's say here we have 1 2 3 6 5 4. So let's see. So for 1 2 3, what is the only force we're going to have on the force of the member? Will be H1 over here. Then we have over here Q1. And we'll have over here Q2. And then for 656, one over here. Q1, Q2, and 2004. So here, so it's 1, 2, 3, 4, 5. Okay, so now what we're going to do is that for each member, 1, 2, 3, 4, 5. Let's write the equilibrium equation. Summation of forces equal to 0. So let's say this was 10 inches, 10 inches, 10 inches. This is 10 inches, 20 inches, 10 inches, 20 inches. Okay, so if we look at the first figure, what should be the equation? We look at one. What should be the equation of equilibrium? R1 minus 10Q1 equal to 0. If we look at 2, what should be the equation? Minus 1600 plus 10Q1 minus 10Q2 equal to 0. Or I can actually write this as 10Q1 minus 10Q2 equal to 1600. Equation 3, I go to this one. What are we going to get? R3 plus 10Q2. Yes.
Can I see the original figure real quick?
You should have your own original figure, no?
I just need to.
I get it. I'm just only like,
Thank you.
here we go. Okay, so what do we have here? R3 plus 10Q2 equal to 0. Now go to 4. What should be the equation in 4? We're going to have H1 minus 10Q1 minus 20Q2 equal to 0. And 5, which would be this one, what we're going to have? 10Q1 plus 20Q2 plus 2000 equal to 0, or I can just rewrite this as depend how we can do this. Minus 10Q1 minus 20 Q2 equal to 2000. Okay, so how many equations do we have? It's not that complicated to find out, no? How many equations? 5 equations. How many unknowns do we have? Let's count them. What are the unknowns that we have? On equation 1, R1 and Q1. On equation 2, what is the new unknown? Q2. On equation 3, R3. In equation 4, H1. And equation 5 is nothing new. So how many unknowns do we have? 5. So is that good or is bad? 5 equations, 5 unknowns, we can go and solve. Yeah.
Why is each one times on 4? Instead of 1.
Okay, good question. We discussed that I think the first day. What do we assume? What is the assumption that we're making about each one of these members? Somebody else can answer. I said that at the beginning of the class. What is the assumption? Is that they are one first member. So basically, what is the assumption of one first member is that each member can only carry the load in what direction? In the axial direction, no? Okay? So basically, if you look at this design, when you do the design of this one, H1 should be, on the ideal case, should be carried by which member? 1, 2, 3, no? And the vertical load R1 should be carried by what? 1, 6. Both these loads are 1, no? But we're assuming that only this one will be carrying the one on the axial direction, one first member, and this one will only be supported by the flange 1, 2, 3. Does that answer the question?
Yeah.
Okay. That's the same thing as that you were doing in statics when you were studying the trusses. You were saying that the trusses were only active in the axial direction, no? No bending. Okay, don't let it. Okay, so solve over here. There's different ways to solve. I know you have amazing calculator and so on, but basically we just tell you one way. Actually, I can show you the MATLAB file and even give it to you. So let's solve using matrices. So let's say I'm going to define a matrix here, A. Well, let's say I'm going to put over here R1, R3, H1. You don't need to do this. It's just for the first time that I do it so that it's clear for everybody. Okay, so let's see. What are the equations that we have over here? So if we look at the first equation, what do we have? R1 will be 1, 0, 0, negative 10, 0, no? Okay, and let's over here, let's call this one now a vector B. Let me do it now, and B will be a vector. So B basically will be containing, if you want, for equations 1, 2, 3, 4, 5. So what is the one that is not functional variable? So here, the right hand side of the equation is equal to what? 0. If we do the same thing for the second equation, you saw that we wrote into this one. So what are you going to have? I1 should be 0, 0, 0, 10, minus 10. And from the second equation, what do we have here? 1600. Equation 3, what do we have? 0, 1, 0, 0, 10. Wait, 1, 2, 3 equation. Yeah, 1 on R3, 10 on Q2, and the right side should be 0. Equation 4, we have R1 0, R2 0, H1 1, Q1 minus 10, Q2 minus 20. And this should be also 0. And the last one we have 0, 0, 0, 10, 20. Oh, we have, sorry, minus 10, minus 20. And then I have over here 2000.
Next, 2000.
No, 2000. Because we moved the Q's to the other side. So actually, if you want, the system of equations can be written as, okay, let me just rewrite everything for the first time. It'll be tedious, but let's do so. We have here 1, 0, 0, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 1, 0, minus 10, 10, 0, negative 10, negative 10, 0, negative 10, 10, negative 20, negative 20, times the variables we have over here are 1, R3, H, Q1, Q2 equal to 0, 1600, 0, 0, 2000. So basically, this is our matrix A. Will be our vector B. So this is our vector B. Okay, so with some very simple math, you find that, let me just call this one over here Q. Or, yeah, Q, doesn't matter. No, I mean, no, okay, let me do it the first time long, it's fine. So we'll find then that R1, R3, H, Q1, Q2 should be equal to what?
should be equal to the inverse of this matrix. I move it to the other side, so it will be inverse of 1, 0, 0, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 1, 0, minus 10, 10, 0, negative 10, negative 10, 0, negative 10, 10, negative 20, negative 20, and you have the 0, 1600, 0, 0, 2000. So basically what you say here is solution. Basically what I'm doing is Q solution equal to inverse of A times B.
Okay, so I know you have 10 different ways to solve this very, very easily. But let's see, before class, yes, we're waiting for this. You can finish copying this. Okay, still thinking. All right, but basically, if we do this, what should we get? Then we'll, so solving, let's say solving using MATLAB. What are we gonna get? We're gonna get, what should we get? We should get I1 equal to, as before, 400 pounds. R3 we had before equal to 1200 pounds. H1 we had equal to negative 2000. Q1 40 pounds per inch. And Q2 negative 120 pound per inch. Okay, as before. So let's see if I can open this now. I'll let you copy this at the bottom. So like I was saying before coming to class, I create a quick MATLAB code for this. Hopefully I save it. I think I save it. I think I'll put in here. I think this is the 3. So I think that was the other problem. Oh. Oh no, that's the other problem. Yeah. Okay, that's the one we're gonna do next. I'm like, I don't remember that one. So videos, I don't think it's 2. Where did I put that one? Huh. I think I put it on lectures, maybe. I know I did it. Here we go. So basically, a little bit different. I created, you see the matrix 0, then I started to put the values one by one. Okay, but if you want, let's execute this file over here. I will give you this file again. You see here the B. So basically, if you look at A, why is this so ugly? Basically, here you see the matrix A that we have created. It will be B. And then once you go and do over here, solve A inverse B, we got the solution. So this will, if you multiply this by 1,000, this will be what? 400 or 1,200 minus 2,000, 40, and minus 120. Okay? Pretty straightforward. So, any questions so far? Okay, so now let's just do for one member. I'm not going to do a lot of them because this is pretty simple. Okay, but let's say like so let's say forces. So if you want, so let's say axial forces on I'm not going to do on all members, but let's say on some members. So let's see what we have. Member. Let's just do a simple one. Member, let's say, all right, I'm going to do a simple one, 5-2. So if I just look at 5-2 again, what did we have at 5-2? 5-2 was the one that was subjected to the $1,600. Q1 over here. Q2 over here. And from the math, what do we know? Q1 was 20, Q2 is minus 120. So really what happens is that Q2 really is going in the opposite direction, no? Okay, so if I needed to do the load distribution, what would that be? What should be the load at here? 0, what should be the load at the tip? 1,600. Okay, and you could do something similar on follow a similar procedure for all other members. Yes.
Usually, like how you get that root diagram.
Okay, so here we are 1,600, no? So if you want to think about it, So we didn't mean before you one can make a cut. But what do we say should be the load at this end? Is it any force being applied at 5? So basically it's 0, no? Okay. Now, and when you look at it, there's one load at the end. I mean, so if you want to be accurate, what you should really do that we did last time, you should do over here what? You should do like a cut. You will have here the S distance. No? This should be what? This should be Q1, correct? And this should be, if I take into consideration the sign, this should be Q2. Okay, so maybe I skip one step. And now, what should be over here the force? It should be F52. Okay, so I know I'm doing everything too small. Now, if you do the summation of forces over here equal to 0, like we did the other, what will you get over here? You will get what?
US.
So you will get Q1 plus Q2 S will be equal to will be negative or will be minus, or will be F52, no? Correct? So this is the equation of this will be the equation of this line. At S equals 0, this is 0. At S equal 10 will be what? 120 plus 40, 160 times 10, 1600. Okay. Yeah, maybe I skip to did that again. Maybe I should have covered, okay? Does that answer the question here? So basically one here we can put now F0, F520 equal to 0, F5210 equals 1600. Okay. Okay, so you can do something similar for all your numbers. What time is it? Okay, so I have another problem which is going to be a lot longer. Now we have time to finish it. Okay, so let me do something. We just did this problem. Let's just do very quick the map and see. I haven't done it, so I don't think I've done it. That's I did it the other day. Let's see. Yes, no, I haven't done it for sure. So this should be, but I should change this then. Come on. Doesn't let me look at my files.